Hello, in this video, I will explain to you on how to solve this problem. A plane is flying horizontally at an altitude of 2 km and a speed of 800 km passes directly over a station. So this is the station here, and we know that the altitude is fancy term for height, so we will have this one here, y is equal to 2 km. And then its speed here, so if we name this x, its speed is the change of this x, so I will have dx dt here, and that dx dt is 800 km per hour. Okay, and the question is asking us find the rate at which the distance from the plane to the station is increasing. So I will have z here, which is the distance from this radar station to the plane. And the question is asking us about dz dt when x is equal to 3 km. Okay, so we need to find out the relationship of x, y, and z. And of course, we have a right angle triangle. We can use the Pythagorean theorem. So we will have z squared here is equal to x squared plus y squared. And then if you see it here, this y is the height of the plane flying, and it does not change because the plane is flying horizontally, right? So the height does not change. Okay, so we can just plug in these two into this equation here. So I have z squared is equal to x squared plus 2 squared. Or we can have z squared here is equal to x squared plus 4. Good. But then we need to find out dz dt. So here we have z squared is equal to x squared plus 4. We can use implicit differentiation with respect to t. Implicit differentiation with respect to t. Okay, on the left hand side here, I have z squared, so we will have 2z, right? So the differentiation of z squared is 2z. However, we need to differentiate with respect to t, so I multiply this by dz dt on the left hand side. And the same for the right hand side, I will have x squared here, so I differentiate it into 2x. But then it with respect to t, so I will have dx dt. And plus 4, it becomes 0. So we can cancel out these two here. And now we have dz dt. dz dt. Let's isolate that. And I will have x divided by z dx dt. Okay, and then if you see z here, we can just use the positive square root, right? Because the distance is always positive. So I will have z here is equal to the square root of x squared plus 4. Actually, it is plus minus, but distance is always positive, so we can just use this one. So we can substitute this z into this z. So we will have dz dt here is equal to x divided by the square root of x squared plus 4, and then multiplied by dx dt. And this is one of the important formula here, and we need to plug in when x is equal to 3 km. Okay, let's clean up our slide. Okay, now all that we need to do is to plug in x is equal to 3 km. So when x is equals to 3 km, right? So we will have dz dt here. And when, the notation of when is like this, and x is equal to 3. Okay, and then this x here is 3, so divided by the square root of 3 squared plus 4. Okay, and then multiplied by dx dt, so I will have 800 like this, and then that will equal to, so I will have 2400 divided by square root of 9 plus 4, so I'll have square root of 13. And I want to rationalize this, so we will have the square root of 13 divided by square root of 13 here. So we will have 2400 divided by, this one will become 13, and multiplied by square root of 13. And the unit here, dz is in kilometer, and dt here is in hour. So that is the exact values. But if you want to calculate the approximate value, you can just plug it into calculator, right? So we will have 2400 divided by 13 multiplied by square root of 13. Okay, and I will have 665.64. Okay, so we'll have 665.64. And the unit here will be in kilometer per hour. Okay, and I think that is the answer for this problem. You can answer it with this. This is the exact values. Or this is the approximate values. And I think that's all for this problem. Hopefully I did not make any mistakes during my calculation. And then finally, thank you for watching. See you in the next video. Bye bye.